we stated previously that the force is going to be equal to a change in momentum due to time. So this is Newton's second law. And what happens, for instance, this is the sum of forces. What happens, for instance, if the sum of forces is in equilibrium? Well, Newton's first law will state that this sum of forces is going to be equal to 0, so the change in momentum due to time is going to be equal to 0. If there is no change in momentum due to time, then the linear momentum is conserved. So, first Newton's law will state a consequence that linear momentum is conserved. For instance, it will state that final momentum equals initial momentum. So the linear momentum conservation is a consequence of first Newton's law. It only happens when the forces are at equilibrium. Imagine we have two objects, one moving towards one direction without initial velocity, and the other one moving towards the other direction with another velocity. Both of them have initial velocity. Then all of a sudden what will happen? They will collide. What happens during the collision? Well, mass 1 is going to exert a force to mass 2. This is the force exerted due to 1. But there is going to be an action-reaction pair. This is force on 1 due to 2, which is opposite direction but same magnitude. These two are action-reaction pairs. This is due to Newton's third law. What happens at the very end? Well, it could happen that mass 1 goes towards the other direction with a final velocity, and mass 2, for instance, goes towards the other direction as well with a final velocity. So both of them change their momentum. But what happens if instead of analyzing mass per mass, we analyze the whole collision as a system? Then there is no going to be any sum of forces because it's going to be equal to 0. I mean, action-reaction pair cancel each other because they have the same magnitude, right? So if there is sum of forces equal to 0, then momentum is conserved. So what is going to happen during the collision? Well, it's going to happen that momentum is conserved. So mass 1, velocity 1 initial, plus mass 2, velocity 2 initial, which is, for instance, the initial momentum of the system, is going to be equal to mass 1, velocity 1 final, plus mass 2, velocity 2 final, which is the linear momentum of the system. So this is initial momentum of the system. This is final momentum of the system. Although the momentum per mass is going to change, the momentum of the system during the collision is conserved. This is the conservation of momentum in collisions.